Hey, Vincent here. Welcome to another CAD tutorial. Today we'll be modeling Too Tall Toby's 240114, the slide hinge. But unlike my other videos, today we'll be doing it in Plasticity. Just a little disclaimer: I'm just started using this program, and it seems to be pretty cool. But the reason why I started instead of doing it in a Libre is because last week I've been traveling, and the only laptop or the only computer I had with me was my MacBook. And unfortunately, a Libre only runs on Windows right now. So, with my Mac, what am I supposed to do? So I gave Plasticity a try, and I kind of like it. I thought I would take you along with kind of the journey that I took in learning Plasticity. And here's this tutorial on how I used it to model Too Tall Toby's part. So before we begin, let's take a look at the drawing again to see how I kind of looked at this and went about modeling this part. So if we look at the diagram, the approach that I took is essentially to build this oval shape base first, and then from that I can then build one side and then build the other side. And a lot of this, there's a lot of symmetry here again here, like it's symmetrical on this side and this side, so there's going to be some mirroring over there. It's symmetrical over here and here, so there's going to be some mirroring over there. And yeah, so this is a pretty simple part to build. I think the only tricky thing, which is actually not so tricky, is just understanding, getting all the dimensions that's required from each of the views here to piece them all together. But other than that, the only problem, or the only troublesome thing I had was just learning Plasticity, because unlike a traditional CAD software, there's really no dimensioning in Plasticity. But we can use a bunch of curves to do that in place of fully constraining everything. So yeah, so that's kind of the approach that I took. So let's get started. All right. So in Plasticity, the first thing is to make sure that the units are correct. So I'm on my Windows machine now, but on a Mac it would be Command, comma. On Windows it's Control, comma, and that gives us this menu. In this fourth option is this grids and units. It's already on millimeters, so we're good. First thing I'm going to do is I'm going to clear the scene. So I'm just going to select this solid, press X to delete it. I'm going to press I believe it's / to kind of give us this view over here to kind of zoom in. But actually, the first thing I'm going to do is I'm actually going to model that oval shape. And in order to do that, I'm going to look at everything from the top-down view. For me, the top-down view, I believe, is Control-2, which it is. But if that's not your shortcut, you can always find everything in this menu that is accessed using the F hotkey, and you can search top. Here it says viewport, navigate to top. That's Control-2 for me, which is what I press. For you might be different, but that's how you get access to it, and you can also assign shortcuts to it. So here I'm at the top view. What I'm going to do is I'm going to first create that outer oval or ellipse shape, and what we're given in the diagram is that we're given the width of the outer ellipse, which is 60 millimeters. That also happens to be the diameter of the arc over there. So in order to model that in, we're actually going to use the center circle tool. So here we can access it on the right-hand side. But for me, I have it as on my Windows machine. It's Alt-Shift-C. So that's what I'm going to press. And I'm going to snap along this Y-axis. I'm just going to click anywhere, press Tab. Now I can enter in 60 and press Enter twice to confirm. Now, in order to get the height or length of this oval, it does give us the end-to-end length of 130. There's no dimensioning in Plasticity, but what we can do is just draw in a line to do that. So using the line tool on the left, for me, it's Shift. The shortcut is Shift A. You can click on the top of this circle that we just created, and then make sure it's 90 degrees. I can then press Tab, and then I can enter in 130. And then press Enter twice to confirm. Now using the Edge Selection tool, so that for me the shortcut is 2, or you can click on this top left over here. I'm going to drag from the bottom right to select both curves, And then what I'm going to press now is I'm going to press G for move, and that'll activate the move tool. And then I'm going to press F for freestyle. And then what I guess is, I don't know if this is a shortcut or a power move or something, but I've seen from another tutorial, if I just right click twice, it will center what I've selected around the origin. Now, before I do that, I'm going to unselect everything. I'm going to reselect everything again. And notice how if I select everything and press G, the pivot is on the center of the line, which is actually what we want. We want the center of the line to be right on the origin. Now, we can always change the pivot here there's this extra menu on the bottom right over here. Changing the pivot, we can do that using the V hotkey. I'm not going to do that. I just want it to be centered on that line right now, which is what we want. So right now the pivot is correct. I press F for freestyle and I right click twice, and then that will center everything, and press return to confirm. And that's all this line is really used for, to center these curves along the origin correctly. So now again, I'm going to have the circle selected. I'm going to press the Alt X is a shortcut for mirror, or we can find it down here on this bottom left tool over here. Alt X, and then I'm going to mirror this circle along the Y axis to bring it onto the other side. Now I'm going to use the line tool again. Again, I can click over here or press Shift A as a shortcut. I can really click anywhere, but the second click, I just want to make sure that it's I get this tan or tangent, I guess, snap enabled. So this makes sure that this line is tangent to both of these circles. I left click and then I right click to confirm. Do that again using the line tool. Click on this curve. Make sure it's tan. Right click to confirm, and then now that's our outer ellipse. Now I'm going to activate the trim tool, which is the scissor icon over here, or the keyboard shortcut T. And then I'm going to just go and select these inside edges that I don't want anymore. And that's done. And press OK. Now, the last thing I need to do before I do anything else is to select everything, all of these edges over here. And on the bottom right there, one of these icons says join, or J is the shortcut, which I usually use over here. It says join curves or sheets, or J as the keyboard shortcut. I'm going to press J, and that makes everything into one edge. Now, in order to do the inside ellipse, all I need to now do is select this edge. I'm going to press O for offset, but I guess it's also one of these menus down here somewhere. I'm not sure which one. This one here, offset curve. I can press O. I can then now press D for distance, and I enter in 10, and then press enter to confirm. And that's the inside ellipse. Now I can select using the face selection. So for me, it's the keyboard shortcut 3, or you can press on this button on the top left for face selection. I can now select this outer face, and it'll give me this extrude menu. I can press D for distance, and here in the drawing, it says that the height of this ellipse is 60. But what I really want is to enter 30. Because then when I press tab, it will actually extrude 30 millimeters the other way. That'll keep everything centered, but it'll give me a total, height of 60. And then press enter twice to confirm. And that's pretty much our base that we're creating. Next thing we're going to move on to is that rectangle, or that square-ish, rectangle-ish thing on the left side that has two fins extruding into it. So looking at this model, I can now switch to the front view, and here I'm going to select the corner rectangle tool, but I'm going to click on the x-axis, and once I start dragging, notice that on the bottom right there's the shortcut, and it tells you to switch from center, or from corner rectangle to center. I can press the C shortcut, which is what I'm going to do, and press C. And we know from our drawing, so now it's centered along the x-axis. We know from our drawing over here, we know that so I guess the height is 30, and we know that the depth is 30, but what we don't know is the distance from the front of this base to the front of this this left side. So, but we don't need to know that immediately. All I'm going to do right here is enter in 30 for the height, and then press enter, and leave it as this little kind of sliver. We know that the depth is 30. So with the face selection mode, I'm going to select the face and I'm going to extrude. And again, I'm going to press D for distance, but I'm entering 30 and then press divided by 2. And that'll give me 15 because I want to then press tab to get that extrusion on both sides, which adds up to 30. And then press enter twice to confirm. Now, if we switch to the front view, I'm actually going to now hide the base because now that'll give me access to this origin. I can actually hide these other curves as well. But what we want to do is basically looking at the drawing, what it gives us, it doesn't give us the distance from the base, the face on the base to the front of the left part. But what it does give us is the front of the left part to the center of the circle on the right part with a length of 125. But then it also gives us the center of the base to the center of the circle of 60. And with these two pieces of information, we know that the center of the base to the front of the face would be 125 minus 60, which is 65. So this face over here must be 65 millimeters from the face over here. So that's what we need to solve for next. In order to do that, I'm going to use this line tool, activate the line tool, and I'm going to click on the origin. I'm going to drag along the X and then press tab, and then now I can enter in 65 and press enter. And that'll give us this edge. Now, in the meantime, I can now show that base again, but now I'm using the body selection. I'm going to select this, this rectangular thing that we created. I'm going to press G to move and then press along the X just to shift it back a little bit, and then right-clicked. Is it right-click? Oh, no. Press OK to confirm. I actually don't need this rectangular curve that I use to create that shape anymore, so I can actually just go and highlight it, press backspace to delete. Now, cool thing with plasticity is now if I switch to face selection, I can push-pull faces. So what I'm going to do is I'm going to select this face, and if I hold down Control while I'm dragging this yellow handle, what it'll allow me to do is it'll allow me to snap to something. And what we want here is just to snap to this face on this base, which is what I'm going to do now. And then press enter twice to confirm. Similarly, now I can click on this face and hold Control again, and it'll allow me to snap. But this time I want to snap to the end of this line that we created. So here it says curve, end, and intersection. We're going to snap to that, snap exactly to that, and then press enter twice to confirm. And now that will give us the proper distance from our base. So if we confirm, looking at the right view, I guess we can't really see the line, but if we hide that, you can see that it's exactly on that line. We don't actually need this line anymore, so I'm just going to highlight it and delete it. But and yeah, so before I do anything, I want to merge or join both of these solids together. So I can click on the two solids from the menus, press Q, and then Q again, and they'll switch the Boolean. They'll give us the Boolean tool, and again, Q on this right menu gives us the union. That's exactly what we want. I can right-click to confirm, and now we have one solid object. Next thing to do is to create those fins, and in order to do that, I'm going to switch over to the top-down view. And here we can see, if we look at the diagram, we can see that the fins kind of go on a 45 degree, but it does intersect with this rectangular left part 4 millimeters down from the front of that face. So again, in order to do that, the only tool we have is this line tool. We can make sure it snaps on the edge and at the end. We can click on that, then we start dragging along the edge. We can press tab and then enter in 4 millimeters. And then press enter twice to confirm. Next thing, I'm going to use the line tool again. I'm going to click and make sure that it intersects with this curve. And end just means it's the end of a curve. Here we drew that 4 millimeter line, so it's the end of that 4 millimeter line. That's what this is telling us. So I just want to click once and then start dragging. But notice that there I can also enter in an angle. If I press tab and then tab again, now I can specify the 45 degree angle that I want. And here I'm just going to extend it all the way out over here. Left click once and then right click to confirm, and that's what we want. Now, if we like rotate the camera around, notice that it's like all the way, it's along this edge. But cool thing about plasticity is that if we have edges that are on the same plane, then if they intersect, then that will allow us to create faces from them. So if I just go and hide the solid, I can show you what I mean. So these two edges right now is just kind of floating because it's floating above the x-axis because it was along that edge that was above the x-axis. But what we can do is just select both of these curves, press the G command, and then hold, and then while I'm dragging this blue arrow, which is the Z axis, I can then press Control. That will allow me to snap, and I'm just going to snap right back down onto the same plane as everything else, and then press Enter to confirm. Now all I need to do left is to use the line tool. Make sure that it snaps onto this point over here. Make sure it's perpendicular and it snaps onto the existing curves that we have. And then I right click to confirm, and now it creates this face for me that now I can select. So using this face selection, I can select this face. It gives me the extrude menu, and from the drawing, it says that the width of these fins are 5 millimeters. So I press D for distance, I enter in 5, but again, I want to divide that by 2. So it's 2.5 millimeters, and then press Tab again, so then it extrudes in both directions, and then press Enter twice to confirm. So if I enable everything now, we can see, oops. If I enable everything, we can see that this tab is created. Now, in order to create the tab on the opposing side, I can just select this extrude that we just created. I'm gonna press this mirror on the bottom. Alt-X is a shortcut, but you can also click on this button. And I want to mirror along this Y axis. I can just press Y on the keyboard, press Enter, and now that gives me the other tab. And now this left side is completely done. So selecting everything, selecting all the solids, I press Q and then Q again to union, right click to confirm, and now I have one full solid. So with the left side done, now we want to create the right side, and we know that from the origin to the circle on the right side, there's this distance of 60 millimeters. So that's what I'm going to do right now. In order to make it a little bit more clear, I'm just going to hide everything for now, and then pan over here using the line tool again. I'm going to click starting from the origin, and then drag along the X, press Tab, and then I'm going to enter in 60 millimeters. Now from the front view, I can see that now I can select the center circle tool, click on that, make sure that it intersects with the end of that line that we just created. So give it a click, start dragging out, press Tab, and we know that in the drawing it says the radius is 10, which means that the diameter must be 20. So we entered that in, and that's done. Now the previous line we created, we don't have any use for that anymore, so we can just go and delete that. And we'll actually do one more thing. We know that this cylinder that gets extruded, there's a hole in it, and the hole is going to be 12 millimeters in diameter. So we can just, using the center circle, just snaps to the center of this existing curve, press Tab, and enter in 12, and now we have that. All right. Because everything's along this x-axis, what we can do now is, using the face selection, just select both of these faces, and now it gives us the extrude menu. We press D for distance, and we know that from the drawing that from end to end, the distance is 120. But again, we want to divide that by 2. So I entered 120 and then /2, and that gives us 60. And when I press Tab, it extrudes from both directions. Press Enter twice to confirm. And that's our little cylindrical hinge piece. Okay, so the last thing we need to do is kind of just create these tabs that kind of stick out. And in order to do that, what I'm going to do is, first we need a position where we want to extrude these tabs. And again, to do that in the drawing, we see that the inside of the tabs are 90 millimeters apart. So if we look at it from the top view, what I then can do is I can just create a line, make sure that it's 90 degrees, and then press Tab to enter in a dimension and press enter 90. Now we need to then, with this line selected, I'm going to press G to allow it to move. Again, the pivot at the center of this line is exactly what I want. But I want to press now, hold down Control and snap it along this x-axis. And optionally, I can also snap it along this face or this outside edge because that's where it eventually needs to intersect. And then right-click to confirm. So now I'm actually going to now hide this cylinder first, because what I'm going to do next is I'm going to duplicate this outer circle, because this outer circle is also used for the tab. So in order to duplicate, I can press Shift D, and that'll automatically give me this move menu. And dragging from this green arrow along the y-axis, I can drag it, and then while I'm dragging, I can press Control. Now I can snap towards the end of the line that we just drew, and that'll give us the proper spot for the circular part of the tab. Now if I switch to the front view, actually before I do anything, I'm going to hide everything because I just want to focus on creating this tab. So one way to do that is to press on this eyeball icon next to all the other curves. The other way is there is this command called hide everything, or I can't exactly remember what it's called. Let me see. Hide unselected. So I just want this circle to be, only have this circle selected. So if I use Shift H or press on this command, hide unselected, it will hide everything else, which is what I want. I'm going to hide unselected. I will now switch to the front view. And here we want to create that 45-degree kind of angle tab. And it's 45 degrees between the two edges along this x-axis. So really, we want the angle to be 45/2 in order for us to achieve that 45-degree angle. So in order to do that, I'm just going to use the line tool, and I'm just going to draw anywhere, but anywhere first. But then I'm just going to press Tab and then Tab again, and then enter in 45/2 as the angle that we want. But I just want to make it a little bit longer. Actually, this is probably fine. Yeah, this is probably fine. So and then right-click to confirm. Now with this curve selected, I am going to press G, and then now I'm going to press F for freestyle. And freestyle allows me then put a point that I want that I can snap onto, or like it's almost like pivot, but it's a point of reference that I can then use to snap onto other things. So I want to place this point right at the end of this curve, and then now I can move it around. And if I intersect it with this circle, if I just move it here, it says tangent, which is exactly what we want. So I'm going to left click and then right click to confirm, and that's exactly what we want. So now this line is tangent to the circle. Now we can just select this line. We can use the mirror tool again, and then we want to mirror it across this this y-axis, and then and that'll give us the edge on the other side. Now to close everything off, I'm just going to use the line and just going to join everything together. Right click, and it's not giving us a face. Why is that? If we rotate the camera around, we notice that, hey, all of this is now relative to the x-axis, whereas we want it relative to the circle that we know is in the correct spot offset on the model. But it's very simple in Plasticity. We just got to select these edges again, press G. We can now hold on to Control, and that allows us to snap. And then we can just snap it. Okay, I actually messed up. I should only be moving things along the y-axis. I select the middle. It's all okay. I can just cancel out of it, press G again. Start by pressing onto this green arrow. Now that snaps along this y-axis. Now I press Control, and then I want to snap it to make it the same. To make it I guess what's it called? To make sure that these edges are now on the same plane as the circle. Right click to confirm. Now it gives me a face that I can select. Now, before I extrude from this face, I'm just using the trim tool to trim the inside of this face, and that's pretty much done. So switching back to the face selection, I can now select this face. Gives me the extrude menu. I press D. I'm going to enter in 10 because that is the, let's see, where does that say? Yeah, so that is the width of this tab, and then press enter twice to confirm. I'm just going to unhide everything now to kind of show what we have. Now, before I do anything, this face over here needs to match up against this body over here. But notice that this body is curved. In Plasticity, if I click on this face and then I press F, I can search for a command called match face. And if I select that, I just now need to select a target face, which is this curved body. And now we notice that it kind of extrudes and matches against this face. So very cool command to know. I press enter or return twice to confirm, and that tab is done. So the thing left is now I can select the tab. I press the mirror tool again. I'm going to mirror it along this y-axis, and that'll give me the tab on the other side. Now selecting all of the solids, I press Q and then Q again, and they'll union everything. Right click to confirm. Now I have a single solid. Last thing now is to actually do that 12 millimeter hole through this cylinder and everything. So I just need to find that curve that represents that 12 millimeter. Here, a bunch of stuff is hidden. I can unhide everything by clicking on this eyeball or unhide on each of these curves. Or there's a command, if I press F and I search for unhide, there's an unhide all, which also has a keyboard shortcut of Alt-H for me. So that will give me access to that curve again. So now with the face selection mode, notice how I can't click on this face, but one way to kind of work around that is I can just click and hold on to the left click as if I'm trying to select that face, but then I can use the scroll wheel and it'll scroll through a bunch of stuff that I'm kind of hovering over. So notice now I'm hovering over the face I do actually want to select. I can now let go of left click, and now that face is selected. I can now press D, and I'm just going to enter some arbitrarily large amount, so like 1,000. But I'm going to press Tab so it goes through both sides. But before we do that, I'm going to click over here. It says Select Target Bodies. So I click on that. I can select the solid that we have, and now it turns into a cut operation. I can press Enter twice, and now that is done. So this is pretty much our part, but Plasticity doesn't have a mass and materials kind of tool, so we kind of have to do that ourselves. And the way that we do that is we first have to make sure everything is one solid, or the thing that we want to measure the mass and volume of. If we click on that solid, on this bottom right corner, it shows us that it gives us the volume here. And here it says that the volume of our part is 260,254.05 millimeters cubed. So which we'll use to calculate the mass. So I'm going to switch over now to the iPad, and we're going to have to do some of this calculation by hand. Hold on a second. Going to the iPad, and okay. So what we're going to do, this is probably, the mass of the part, I'm just going to say is about 2,030 grams. That is going to be the answer. But if you don't know how to do the math, this is for total newbies like myself. I'm going to be showing you every single step that's taken to calculate, including doing some of these basic unit conversion stuff. If you know unit conversions, you can skip to the end. We're done with the model. This is the piece. Good job. If you don't know how to do the unit conversions, and this is for like really basic, I guess, or introduction to CAD, we're going to run through some manual math that we're doing on paper, or I guess on the iPad. So again, I'm going to say here, we have our volume is, I'm looking at the screen right now, 260,254.05 millimeters cubed. And from the 2 the material, it says that the density is 7,800 kilograms per meters cubed. And in order to convert, and what we want is the mass. So in order to get the mass, it would be volume times density. But we need to convert that into units that we can work with. So 7,800, we're going to multiply that by 1,000 grams is 1 kilogram. That's our first unit conversion. So kilograms crosses out. And then the next thing is we're going to multiply that by is that we have 1 meter is equivalent to 1,000 millimeter, and we need everything cubed. So when we do the cube, this part and this part gets crossed out. So what we end up with is 7,800 times 1,000 grams over, and we have 1,000 cubed millimeters cubed, right? And the 1,000 over here and 1,000 over here, we convert that now. That crosses out. So we really have 7,800 grams over 1,000 squared millimeters cubed. And now if we just do that division, so 7,800 over divided by 1,000 and divide that by 1,000 again, we get 0.0078 grams per millimeters cubed. So given the volume that we have of 260,254.05 millimeters, we multiply that by 0.0078 grams per millimeters cubed. That will give us our volume in, that will give us our mass in grams. So I'm going to switch back now to the computer. I'm going to run calculator. So again, over here, calculator, 260,254.05 times 0.0078. That gives us our answer of 2,029 grams, 29.98 grams. Round that up to 2,030 grams. And that is our answer. If we watch the video, go to the answer revealed. 2,030 grams. 2,030 grams. And that is the solution. So thank you for watching. I know this is a long one because I have not used plasticity before. It took me a while to learn it, but hopefully this was helpful. Yeah. Bye. See you next time.